Continuing along, when the value of x bar could occur by chance alone, we call the result not statistically significant. In this case, the null hypothesis HO cannot be rejected, and we fail to reject the null hypothesis. So we've seen two different things you could say: reject the null hypothesis, or fail to reject the null hypothesis. We cannot accept the null hypothesis since you would need to measure the whole population to know the actual value of mu. So either reject or fail to reject. You can't accept because the null hypothesis is mu is some number, and there's no way to prove mu is that number. And then we're talking about declaring a test statistic. We're going to use z as our test statistic for now. We use z to analyze sample means. If the population has a normal distribution with standard deviation sigma, then z, computed by the formula x bar minus mu divided by sigma over root n, determines how far x bar is from mu, since it's just the number of standard deviations. So it's how many standard deviations x bar is away from mu, and since x bar has a normal distribution, that tells you the probability that it could be that far away, because you could use the z-tables to compute probabilities. In that line of thinking, values larger than 2 or smaller than minus 2 give evidence against the mean used in the formula. That's because 95% of the time, z comes out between 2 and minus 2. And so if you don't get between 2 and minus 2, it's considered an unusual value. And one way to get an unusual value is to use the wrong value for mu in the formula. So that's the thinking. If I get an unusual z value, maybe mu is wrong. On the other hand, maybe x bar was an unusual value to begin with, and mu is correct. That's the thing we have to think about at all times. So we actually never know for sure whether something happened or not, or whether the mean is that number or not. We just have an idea that it's looking like it might not be, or it looks like it could be. And so if it's looking like it might not be, we say the results are statistically significant. If it's looking like the mean could be that number, the results are considered not statistically significant. Okay, moving right along.